Okay, this video basically cover our module 5. Last time, if you still remember, we already go through our module 5 and we mix with module 6. And last class we did a group assignment, which is you need to develop your own circuit from what you have learned based on the notes I provided, isn't it? So I need to conclude our module 5, which is on the problem statement. What we're going to look is on the designing and combination circuit and derivations Boolean expression. So if you go through step by step of designing combination circuit, what you need to do first is to understand the problem, what you need to solve. And then the second is convert the problem statement to Boolean expressions or truth tables. Once you get a truth table, it's quite easy for you to understand the full overview, whichever is most natural for the given problem. And then you can simplify your truth table using your Boolean algebra, rows, and also the easiest ways of using a K-map or other StatNet. But the easiest way is using K-map. But you need to also know how to simplify your truth table using your Boolean algebra. And then fourth is you need to draw the circuit from your simplified output. So after you get the simplification of your Boolean algebra, you're going to simplify it and you will draw the circuit. Fifth, you need to convert the simplified circuit to universal gates only, which is for SOP you need to use AND gate only. For POS you need to use OR gate only. So please bear in your mind, please remind and remember SOP, which is using NAND, and POS using NOR gates. And the sixth step is redraw the final circuit using dual symbols. So this also you already look into how you're going to draw using your dual symbol. So it is basically a first step is understanding, and then let me delete first. Okay, and then after that you need to convert and simplify, draw, convert again, and redraw again. So that is a state. So what from all the state, basically there is a critical step is step 1, which is you need to determine 3 things before you can understand basically what your question asking for. So how many inputs, and give it variable name, whether it is A, B, C, D until Z. What is the variable and how many? So how many input, and then how many output do you have? So you can see it using your truth tables or also using your Boolean algebra. And if more than one output, treat each output separately. You need to separate your output. If let's say normally you're going to have one which is F or Y or also Z as your output, but if you look into your module 6 that you already learned on your full adder and half adder, you can see that there is 2 output, isn't it? So you need to know also how many output, similar to scenario that you already learned, which is on your full adder and half adder, which is there are 2 output. And you need to design a circuit for each output. and finally you're going to convert them together, because basically all these output are linked together to use the same variables of same input. And third is, what is relationship between the output and also the input. This is you're going to see on the truth table of your Boolean algebra, or maybe using your K-maps. Here is the example. If let's say you were given the equation, so you need to read and then you need to fully understand what is the scenario. So if let's say you're given this kind of question, in a certain chemical processing plant, a liquid chemical is used in a manufacturing process. The chemical is stored in 3 different tanks. You can see that there is informations about the input or also output. It depends, but you need to understand whether this 3 is input or output. A level sensor in each tank provides a high voltage when the level of chemical in the tank drops below a specific point. And you need to also design a circuit that monitors the chemical level in each tanks and indicates when the level in any 2 of the tank drop below the specific point. So you need to know also about the high. If high is going to be a below, and 2 of the tank minimums drop below the specific point. So the solution, you need to know that there is 3 tanks, or we can call it as A, B, or C, and then it drop below specific point, it will be high, which is, we know that high is 1, and another one is going to be low, which is 0. So output 1 we call as X, produce a high inactive, and then relationship any 2 tank below specified point has a logic 1, the output active is high. Then you need to know that there is a 3 tank, which is A, B, and C. So this is the level of your tank. If it is a low, then the tank will be high. Low than the, or drop below the specific point, which is specific point is below, then that is going to be high. So convert to standard form. Truth table, the easiest in the case. So normally you can see that you have 3 input, so you have 8 possibilities, isn't it? So this is the possibilities, and you can see that if let's say 2 inputs are having below than expected levels, so it's going to be high in your output, right? So you can check over here. Input a high, which is 1, and else low is 0. So high, no input 1, and output will be 1 when it produces high. So you can see over here, if let's say you have this one, input 1 only having high, input 1 only having high, so over here you can see 1, 2, minimum 2, you're going to get a high for your output, similar to this case, this case, this case. So that's why you're going to get your truth table like this. Then you convert this truth table to your K-maps, and you're going to simplify your Boolean algebra. So it's quite easy, because last time we already looked into how you're going to convert and how you're going to simplify your K-map, isn't it? So this is the simplification equation. X equal to AB plus AC plus BC. Then later on you need to know that you need to draw the circuit. So this is the Boolean equation and you have three input, and you can see that this is A dot B, A dot C, B dot C. So you have three AND gate and you have OR gate. So your OR gate having the three inputs. So that's why going to get this circuit as the combinations for your case. So similar from this example also, you can also implement the circuit and convert it in using the universal gate. You need to know this is the basic gate. So please look back, what is universal gate? We already learned it on our module 3. And then final, draw circuit using dual symbol. So this is the circuit, and then you're going to draw using your universal gate. And will be this one, replace it, then you get this kind of circuit. So from this one, if you look into this, you can get your output and simplify it. This one is using the NAND gate as the universal gate, and this one you use your NOR gate. So it's depend on the question whether it asks you to draw using NAND gate or NOR gates. So this one is example, so you need to draw both. Sorry, okay, this one. This is the NOR gate circuit, and you're going to get this same like before this. The Boolean equation is not going to be changed. The change is only on how you draw your circuit using different kind of a logic gate. And this one is dual symbols using NAND gate only. This one we already look before this, but this is your dual symbols using your NAND gate. This is your dual symbol, and this one is NOR gate. So you're going to change this part. This is also, you can change it, so same, you get a similar output. So example, there is also another example, you might also try it. You can screenshot this this example, and you can try the step by step. So this is how you need to convert it. First you need to understand, and then you're going to see the truth tables. After you have a truth table, you're going to convert it into your K-maps, and then draw the simplified circuit. After that, you're going to use universal gates and also dual gates. So you can try it. And example, direct to Boolean expression. So this is another example also, you can try it. So I just go through but basically this step is similar. So this is the extra notes what you learned in your combination logic circuit. You have a logic circuit, universal properties, dual symbols, problem statement, designing combination circuit. So basically on your logic circuit, what you look, which is on the NO gate, and then NO inverse, you can see the gate, the output, the expressions, the conditions for NO gate, while for NO inverse, you are looking on the complements, and then gates, output, and expressions. Basically it is a POS. Then what you look also on the universal property, you can see that there is a advantages, which is one type of gate only, reduce cost, and also you can reuse the gate. And normally it is under SOP for NAND, and no is under POS. Please remember this. And under SOP you can see uh, what functions that normally is used for NAND functions, which is not, and, or, and then no. While for no function is not O. So this is different like this. This is the levels of your circuit, and then N, you can see also this part, and lastly is a NAND gate for your circuit. There is also dual symbols. You can see the purpose and converting, what you look into simplify the reading of the schematic. And there you can see the SOP and POS. Normally you already use it from your module 4. And this is the problem statement, designing combination circuit. You have learned a 6 step. First, understanding, convert problem to booleans or truth table, and then simplify using boolean algebra or K-maps, and then draw simplified circuit, convert to universal gates only, basically SOP for NAND and POS for no, and lastly redraw final circuit using a dual symbols. So that is for module 5. Later on you're going to look into your module 6. We're going to finish it, and I also already upload your lab 2, and also your and also a past year. You can see there is 3 set of past year I already upload also. Please try it, and later on we're going to discuss on our test 2, what type of the question, when it's going to happen, etc. So stay tuned, and I'm going and after this please check your next video so you can finish your module 5. Thank you, and have a good day. Sorry, bye bye.